So hi everyone, in this video we are trying to solve this Leetcode problem named as valid binary search tree. So the problem statement is very simple. It says that given the root of the binary tree, determine if it is a valid BST or not. Okay, if it is valid BST, then you have just written true, and if it not satisfy the property of BST, then you have just written the false. Okay, so first of all, we have to understand what is BST. So we already know that what is BST in our college days, but I explain you again. So suppose in this tree, in this example, one, this is given the tree, and the root node of two, it is given in the boolean name as is valid BST. So given the root node 2 in the question, now iterate in this tree as a left node and as a right node, then check that if my left node means my left child is always less than my parent node. Yes, one is always less than my parent node. And whenever we are going to the right side of the tree and check, my current node is 3 and it is always greater than my parent node or not. So if it is valid, so means if it is greater than my parent node, so this means it is valid because BST say that my current node is always to the left side is always less than the node, and my current node is always to the right of my parent node, it is always greater than the parent node value. So that satisfies both the conditions. So here in example 1 it is BST. So let's come to example 2, and it written as output as false. This means it is not a valid BST. Now check why it's invalid the property of BST. So if I check the child as 1 and check it is present to the left of my parent node, that was 5, so it is always less than my parent node. So yeah, it's okay because 1 is always less than my parent node, so it satisfies the property of BST. So up to the tree here it is a BST. Now I check for value 4. Now I check that 4 value is on the right side of my parent node. So this means 4 is always have to greater than the value as my parent node. But here 4 is less than my parent node because my parent node is 5 and 4 is 4. So that means it's invalid the property of BST, because in BST the value present to the right side of my parent node is always greater than my parent node, but here 4 is not greater than as 5, so this means it invalid the property of BST and you have to just return false. So this means in entire tree, whenever I got at any valid point I get a value false, means I get the invalid case of BST, then I just return the false. So this means I use a recursive call and for left and right, and in any of recursive call if I get the value of false, so this means you have to return false. So this means I use and% here and operator here. Okay, so and also given that the range of node is 10 power 31 minus 1, so this is the integer range. Okay, so how we solve this question? So my intuition is very simple. I always give a range to for any node. Suppose this is my parent node and this is my as given as initial node as root. Now I give a range from minus infinite to plus infinite. So this means to lie in the range of minus infinite to plus infinite. Now I iterate in the left recursive call, and for node 1 I update our range like minus infinite to value of 2 and check is my 1 is in the range of minus infinite to 2. Yeah, it is in the range of, so it's okay. Now for right call I update range like my for value 3 my left range is 2 and my right range is plus infinity. Now I check that my 3 value is in the lie in the range of 2 to plus infinite. Yeah, it is lie in the range of 2 to plus infinite. So that is also valid, and all the node get rest means I explore all the node, then I just return true, and at the root node I get a value of true, and that was value BST. Now I run for example 2 and check. Okay, now 5 lie in the range of minus infinite to plus infinite. Yes, so it is valid. Now I left recall means I call left recursion. Now for value node 1 I update our range like minus infinite to plus 5 and check, is my 1 lie in minus infinite to plus 5? Yeah, it is lie in minus infinite to plus 1. Now for recursion, now for value 4 which is on the right side of my parent node, now I need to call my right recursion call. Now I update range for 4. How? I give a left range as up to 5 and my right range up to plus infinite. Now I check, is my 4 lie in the range of plus 5 to plus infinity? No, 4 is not lie in the range of plus 5 to infinity. So that means here I got a wrong range. Basically for it not, because basically 4 is always greater than 5, but it not lie in the range of plus 5 to infinite. So that means it is not in the range. So that means it is a invalid case and it is not a BST. So I written here as a left call as a right call as a false. So overall I get a value of false. So that this means it is not a follow the BST property. Okay. So how I code this, and one thing I update here, that node value is always range in minus infinite to plus infinite. So you have to taken means I'm not try to use like int max and int min, because int max range itself 2 power 31 minus 1. So I use here like long max. Okay, I use like long max. Okay. So first of all I code it and then I explain you what is happening. So so here, so this is an implementation part. So basically I pass our root, and this is left range and this is right range. So basically for value root, here for example 2 which is 5 and for example 1 which is 2. So I pass minus infinite and plus infinite as long min and long max. Now I call this solve function. Now if my root value is less than my minus infinite, so this means I I am not in the range and I return BST as a false. If my current node value is outside of the plus infinite range, then I also not in line in the range, then I return as false. So now I am not in a BST. So here it is in the range of basically two line plus infinite minus infinite to plus infinite. Now I call my left recursion call, and when I call my left recursion call, then I know that my left range is always same. So this means my left range, here see that my left range is always same as left range, but now my right range was updated as 2. So this means for left call my right range is nothing but root value, means my parent root value. So my right range was updated as root value for left recursion call. And for right recursion call, I know that my my left my left range is 2 and my right range is always same. So this means my right range is always same for right recursion call, and my left range is 2. For node value 3, my left range is 2 and my right range is infinite. So I update here like my left range is root value and my right range is right range. So basically I update range as I iterate depth DFS in the tree. I update the range as left range and right range. Okay, so now I have to try the test case. And obvious, the node value is int max and int min, so I use long as long max range and min range. Okay, now I try to submit. Yeah, it passed all the test case. So thank you for